experimenting with RCT, randomized controlled trial, as a method. So in these two experiments, what he has done that we have doctors who are basically not doctors, performing as doctors in our villages and also cities. Those who come and give you injection or prescribe medicines. Those doctors, despite being trained, are helping a population to sustain, to live a healthy life. What they did, Abhijit Banerjee, in the left-hand side, this was published in the magazine Science. What he did, he trained one group of informal care providers while leaving the another group as a control group without any training. So those who got the training led to better healthcare facilities, better health conditions in comparison to those who didn't. So this is, you may say, sir, this seems quite very obvious, natural, but this seems natural to us. But to prove it natural by experimenting in the field is a different thing. That thing has really happened. In the other exercise, what he does, he need to spread some information. Gossips, rumors, all spread like wildfire in things. What he did, he asked the individuals in a village to identify a central person, a nodal person. It may not be a panchayat. We generally see that see people saying that a particular person is a DBC, because you say anything, it will be disseminated in a flash, because he would spread the thing like anything. So ये जो gossip होती है, जो rumors होती हैं, it need to be spread. Also the news and information also is supposed to be spread, because if you do not have information about a particular infrastructure or particular provision being provided, then you cannot you would say that I do not have access. To have access is the first thing to have access, to have information. So what they did, they identified the central person who can spread the gossip, and through randomized controlled trial method, through experiment, they dropped the bomb of the information upon that particular individual, and found that the central person identified by the community versus the central person or the panchayat or anybody whom the administration identifies, these two individuals and their results, their outputs varies tremendously. If a community is identifying a person as a central person, the news or the information spreads and the materialization happens at a faster rate, at a very positive rate than a person identified by the administration. So this is how experiments are being done, and this is not a matter of 1, 2, 3 weeks or months. This is a matter of, in one other experiment, what he did, he basically give lentils. There were 3 groups where the regular primary healthcare services were provided. In the other group, primary healthcare services provided, or say immunization was provided. And once a person comes for the immunization, she was given a bag of lentils, or say a bag of dal. This was second condition. The third condition was where the primary services was not provided, and in fact lentils were also not provided. So within the span of time, they saw that in 2 places where the experiments were regular, where the service provisioning were regular, the place where lentils are provided when the person comes for immunization, the immunization rate has increased. Because it is not only through regularization of service, but also some form of incentive that you can achieve health for all, which is one of our goals. So this was one of the very interesting experimental design by Vijit Banerjee and Esther Duflo. Now coming to experimental designs, there are 2 experimental designs I talked about. Randomized control trial, there is very random, nobody is selected beforehand. But there are also quasi-experimental designs that you're not creating a control group whom you're not creating anything, which is kept at the mercy, and the other group where you are basically providing some form of training. These two things are very difficult in quasi-experimental design, because here we can compare 2-3 groups where you can basically compare different set of education being provided to students in 2 different schools and compare them. That particular board is IGSCSC and the particular board is ICSC. You compare the two. This is quasi-experimental design. And the pre-post design, that you are basically introducing a new training program. Before introducing, you look at their productivity, and you provide the training, and then look at their productivity, whether it's increased or not. But it is very debatable method or design, because the productivity increase maybe because of time, because because that could be a time of festivals, that could be a time of appreciation. Before the time of appreciation, everybody tends to work very diligently, very productively. Another, we have testing effects, we have maturation. I will not go into that. Now, there are basically 3 variables in experimental research. First is the dependent variable and the confounding variable. Most of us know this formula, that's regression formula, y is equals to a plus bx. That y regress upon x, that with the change in x, the independent variable, what would be the change we can observe quantitatively in y. So in the formula, y is equals to a plus, there is also an epsilon, there is also an e. Y is equals to a plus bx plus e. E is basically the confounding variable, the variable which we cannot account for. It is not at all possible for us to bring into all the variables. So before making your judgment on the quantitative technique or the results that you have got, always be aware of the variables which cannot be accounted for. So that is our confounding variable. That is a very important factor in experimental research, but also in survey experiments while you perform statistical analysis. Now, once you are aware of the fact, you collect the data. You collect it from the field. But it is always advisable that if you collect your data, you tabulate it, and data should go through form of management. Data management is very important before any descriptive or inferential statistics. First is, here the error should be identified. That whether I have included, or there is a data mismatch, or I have asked questions, I have got responses which does not match with the responses which were there in my question. These are basic elemental consideration. Then we need to remove the duplicates. If a particular household has been questioned, that enthusiastic respondent who wants to be questioned twice, he gives you responses 2 times, it is important that you remove the duplicate one. Third is the correct inconsistency, that your formats and units should be standardized. In some observation you write 3.00, in the other response you write 3, in the other response you write 2.00, in the next one you write 2. So 2.00 is not same as 2. You are putting decimals in one and leaving other without decimals. So if your data is a continuous data, your value could range from 2.4 to 3, that it could be 2.14, 2.75. Then it is advisable they keep the data in decimals, 2.00. Otherwise, it is advisable that if you have categorical data, keep it as 2. 0.00 is not at all required and make the whole data structure very cumbersome. Handling outliers and typos, that you ask a particular question, that what is the weight of your household, and in some of the recordings in your Excel sheet, you find that the data is 300. 300 kgs is, I think, is quite an outlier. We have individuals weighing 300 kgs, but it is not possible in your field. If you think, then it is advisable that you look and rectify the typos. There are many typos when we feed the data. And the last is the handling of outliers. What are the outliers? Outliers are fundamentally the extreme values. For instance, if I have data, say 20, 17, 10, 12, 25, and the last one is 1,75,000. That 1,75,000, despite showing a very good picture, is an outlier, because if you find the average income or average of that particular number, it will go into lakhs, with people being at the range of 25-30 will be remaining outside, very far away from the mean. That if you say the particular village's average salary is 75,000, with most of the households not getting more than 10,000, it makes a very bad judgment. So it is important that you handle the outliers, or the extreme values should be removed before we come. So, but also we find missing data. Once we remove that particular element, outlier, we see that, oh, my student or I have missed that particular data. I could not collect, or the respondent has not given a data. In case of missing data, it is important that you do some form of check. You can delete, but delete is not an option, because as you delete the whole set of information that is being disseminated. You delete a row, you're deleting a respondent. That means a lot. What we can do? We can do imputation. We can insert the missing values. Missing values can be imputed if it is say a continuous data. It can be imputed through finding of the central tendency or the average. It can be median, it can be mode, it can be mean. You fill in that particular data with the mean, median, or mode of the whole data set. Otherwise, if it is a categorical, that you need to fill the category. You like the thing, you didn't like the thing. From 1 to 5, you assign a number. That is basically a category. You cannot have 4.5, because that means nothing. It can be 1, 2, 3, or 5. It is a discrete data set. So in case of discrete and categorical, you fill in that missing data data with the category which has the highest frequency. If the highest frequency says that we don't like, it is advisable that you particularly fill the missing value as I really don't like, a value of 1. Then also we can use interpolation and regression method, that if a particular value, if particular x value is this, what would be the y? This is a very sophisticated technique, that estimating the value of y based on the value of x. Instead, we can do interpolation. Interpolation is a method where you give data or assign a data between two values. That if one value is 5, the other value is 7.8, you basically interpolate the data between these two observations, that let us make this 6.5.